Hi everyone, so today we're going to be talking about multi-step inequalities and how to solve and graph them. Multi-step inequalities are really close and similar to just one or two step inequalities. Same thing as the equations. The biggest difference between inequalities and equations are when we divide or multiply by a negative, it flip-flops the inequality sign, but we'll go through an example with it. Let's just get started. So the first example is 2u minus 7 plus 5u is greater than 14. So the first thing we're going to do is combine like terms. And the like terms are the things with the same variable, like they both have the same variable or they both don't have a variable. In this case, the 2u and the 5u are like terms because they both have u's, which means we can add them together. So 2u plus 5u is the same thing as saying 2 plus 5 and then tacking a u onto it. We know that 2 plus 5 is 7, so we're going to say 7u. And then that minus 7 right there, it doesn't have a like term, so I'm just going to rewrite it as minus 7. Then we can write it as greater than 14. Okay, now this looks more like a two-step inequality that we were solving in the last video. So what we're going to do from here is get the u by itself, which means I need to move the negative 7 and then the 7 that's in front of the u. We're going to move the negative 7 first because it's adding or subtracting. And the way we're going to move it is by adding the 7. The reason why we add is because it's a minus 7 to begin with. So to get rid of it, we have to add. We have to do the opposite. And I'm going to draw the line. Just because what we do to one side, we have to do to the other. This kind of keeps our work a little bit more organized. So we know the minus 7 and the plus 7 that's on the left side cancel each other out. And we're just left with 7u on the left side. And then we have 14 plus 7 on the right side, which gives me 21. All right, now, and I haven't multiplied or divided by a negative number, so the inequality sign stays the same. Now what we're going to do is get rid of the 7 in front of the u. Right now the 7 is multiplying the u, so to get rid of it, we're going to divide each side by 7. The 7's on the left side cancel each other out, and we're just left with u, which is what we wanted. Then 7 divided by 21 is 3. And once again, because we didn't divide or multiply by a negative number, it was a positive number, the inequality sign stays the same. So my answer is u is greater than 3. Now, that's a portion of our answer, but now we have to graph it. So when we graph it on a number line, you're going to get this number line, and it could have several different numbers. We could, like, let's say that it starts with 1, 2, 3, 0, -1. We could keep on moving that through, but when I have greater than, if you remember the rules, greater than or less than is an open dot, and then greater than or equal to or less than or equal to is a filled in dot. And so because it's just greater than, we're going to put an open dot at 3, what our answer is. And then because the variable is on the left side, the arrow points the way that we want our arrow to point. And so if you kind of look right there, the arrow points towards the right. So, or the greater than sign points towards the right. So we're going to have an arrow that also points towards the right. And that's how we graph that. Okay, now let's go through the second example. The second example is -3, and then in parentheses x plus 2 plus 5 is less than 35. Okay, so what we want to do here is we want to get rid of the parentheses first. The way we get rid of the parentheses is by distributing the -3 inside the parentheses. So -3 times x gives me -3x, and the -3 times 2 gives me a -6. Then we can add just that 5 because we didn't do anything to it. It's less than 35. Now the next step is kind of like what we did with number 1. We're going to combine like terms. In this case, our like terms are the things without the x's, which are the -6 and the 5. So the -3x I'm just going to rewrite because there was no like terms for that, so it stays the same. And then we've got -6 and 5, which gives me -1. And then that's less than 35. Now it looks more like a two-step equation. So we want to get rid of the -1 and the -3. The first thing we're going to do is get rid of the -1 by adding 1 to each side. So now I have -3x and then is less than 35 because the 1's cancel out on the left side, and then 35 plus 1, or sorry, that should be a 36. And then 35 plus 1 is 36. obviously, and then we want to get rid of the negative 3, so to get rid of the negative 3, right now it's multiplying the x, so we're going to divide by negative 3 on both sides. The negative 3's on the left side cancel out, we're just left with x, and then 36 divided by negative 3 gives me negative 12. Now, because I divided by a negative number, the inequality sign flips so that it's now a greater than sign instead of a less than sign. And that, again, is because I divided by a negative number. So our answer is x is greater than negative 12. But as we kind of talked about last time, that's only half of our answer, so we've got to graph it now. I'm going to just put negative 12 right in the middle, which makes this negative 11 and this negative 13. And then because it's just greater than, we know it's an open dot, and then the inequality points the same way that we want to go because the variable's on the left side, and so it points that way, and that's our graph. Okay, let's go through the next example. So the third example is 4 in parentheses w minus 10 minus 4 in parentheses w plus 3 is less than or equal to negative 10. And once again, the first step is to just get rid of all of the parentheses, and the way that we do that is with the distributive property. So we're going to distribute the 4 and the negative 4 into both parentheses. The positive 4 goes into the first set of parentheses, and then the negative 4 goes into the second set, because that's just kind of the way that it's laid out. So for the first set of parentheses, we have 4 times w, which gives us 4w, and then 4 times negative 10 gives me negative 40. And now, for the second set of parentheses, there's a 4 in front of it, but that 4 is negative, and so we have to distribute a negative 4, multiply each chunk by negative 4. So we have negative 4 times w, which would give me a negative 4w, and then a negative 4 times 3, which gives me negative 12, and then that's less than or equal to negative 10. Now we're going to combine like terms, and this one actually has 2 sets of like terms. So we have the 4w and the negative 4w. Those both have w's, so they're considered like terms. And then we have a negative 40 and a negative 12. Because those both don't have w's, they're also considered like terms. So let's start with the w ones. We've got 4w minus 4w. 4w minus 4w is actually 0w. I could write 0w, but I can also just kind of cancel them out, because 4 minus 4 is 0. They cancel each other out. Then we have negative 40 and negative 12. When I combine those two, I get negative 52. So now I have this equation that says negative 52 is less than or equal to negative 10. Now, normally, if this was an equal sign, it wouldn't make sense, because the w or the variable canceled out, and 52 doesn't equal negative 10. It doesn't make sense. What's our answer? But this one is an inequality, and so what we have to do is kind of think about this and see if it makes sense. So is negative 52 less than or equal to negative 10? Well, we know it's not equal to, but is it less than negative 10? Yeah, negative 52 is way less than negative 10. And so this makes sense. Even though it's not equal to, we know that it's less than, and so it makes sense. Like, I can put a check mark next to it. And because it makes sense, but there's no variable, my answer is that it's all real numbers. Because it makes sense. Now, if it didn't make sense, or if it said like negative 52 is greater than negative 10, like that doesn't make sense, then it would be no solution. So this one's weird because we graph our solutions, right? Now, we could literally have any numbers on here, 0, 1, 2, 3. Because it's all real numbers, we're just going to draw a straight line right along the top. It's all numbers, so we just put an arrow the whole way through. There's no dots or anything like that, open circles, closed circles, because all of the numbers are included. If it was no solution, you just wouldn't graph anything. Okay, now let's just go through one more example. Number 4. And this one says negative 1, parenthesis x minus 1 is greater than negative 6, parenthesis x plus 1 minus 8. Okay, once again, first step is to get rid of the parentheses by distributing. So we're going to distribute on the left side and the right side this time. Okay, so on the left side, we've got negative 1 times x gives me negative 1x. Negative 1 times negative 1 gives me a positive 1, so I'm going to say plus 1, greater than. Now we're going to distribute the negative 6. So negative 6 times x gives me negative 6x. Then negative 6 times 1 gives me negative 6. And then that minus 8 wasn't a part of the parentheses, so we just rewrite it. Now we're going to combine like terms. On the left side, there's no like terms. There's something with an x and something without an x, so we can't combine those. But on the right side, we have a negative 6 and a negative 8. Those both don't have x's, so we can combine them. I'm just going to rewrite the left side. And then we have negative 6x, because that one didn't have a like term, and negative 6 minus 8 gives me negative 14. Okay, so when you have an x on both sides of your equation or inequality, what you want to do is get the x's on one side of the equation and then things without the x's on the other side. What I would do is I'd actually put the x's on the left side. Normally it doesn't really matter, and it still doesn't matter in this case, but a kind of a trick. Remember, when we're graphing, we really like the variable is on the left side. So when you have the variable on both sides, you want to shove the variable over or move the variables in such a way so that it stays on the left side. So to move something to the left, or move the x to the left side, what I'm going to do is add 6x to each side. And when I add 6x to this side, I'm going to only add it to the x portion. I'm not going to add it to the thing that doesn't have an x, because we can only add like terms. So we've got negative 1x and positive 6x. Well, that gives me a 5x, and then the plus 1 just kind of drops down. And then the negative 6 and positive 6 on the right side cancel out, and I'm left with negative 14 right here. Okay, now it looks like a two-step equation, or inequality, which means I'm going to move the 5 and the 1. To move the 1, I would subtract 1 from each side. So now I'm left with 5x, the 1's cancel out, and negative 14 minus 1 gives me negative 15. The inequality, we didn't multiply or divide by a negative number, so it doesn't switch. And then we still want to get the x by itself, which means we've got to get rid of the 5. To get rid of the 5, we divide by 5 on each side, because it's multiplying the x right now, so we have to do the opposite. 5's on the left side cancel out, we get x. And then negative 15 divided by 5 gives me negative 3. But even though we divided a negative number, we didn't divide by a negative number. And so the inequality stays the same, which means I get x is greater than negative 3. Here's our graph. Let's say we have negative 3, negative 2, negative 1. It's greater than, which has been all of the examples, which gives me an open dot. And then because this inequality right here is pointing towards the right, we're also going to point our arrow towards the right. And there we have it, our answer and graph for the last example.